So today, we're doing a deep dive into something that feels almost invisible. The rapid expansion of artificial intelligence and, well, its environmental footprint.
Exactly.
We're looking at some fantastic sources from science educators, and they call it the carbon cost of our clicks.
A great way to put it.
Our mission here is to really get a handle on the physical reality behind all these sleek, virtual AI tools we're all using.
And we have to start with a number that it's just shocking. Especially if you live anywhere that's dealing with water stress.
Okay.
A single, typical, large data center, the kind that supports AI, can use millions of gallons of fresh water every single year for cooling.
Millions.
Yeah. To put that in perspective, that's about the same amount of water a whole town of 30,000 people would use in a year.
Wow. That's a stunning trade-off. We're actually, in some cases, prioritizing this tech over community water security.
That's the reality of it.
Okay, so let's unpack this. If that's the water cost, what's actually powering the AI in the first place? I mean, we need to look past the app on the screen.
Oh, the infrastructure is enormous, and the demand is it's skyrocketing. Data centers are already one of the fastest growing sources of electricity demand in the world.
Right.
And the International Energy Agency, they're projecting that electricity use could more than double by 2030.
And is AI the main driver there?
It is absolutely the primary catalyst for that spike.
Which brings us to some pretty staggering specifics I saw. The energy needed just to train a single large generative AI model.
Before it answers a single query.
Exactly. It can consume up to 1,287 megawatt hours of electricity.
Wait, so just to be clear, one model's training, it's like powering around 120 average U.S. homes for an entire year.
That's the number. And it generates over 550 tons of co-reuse in the process.
The initial investment, just in terms of energy to get the system running, it's just breathtaking.
And that energy consumption ties directly back to what you said at the start, the water crisis.
Precisely. Cooling is the big issue. For every kilowatt hour of electricity that's used, you might need around 2 liters of water just to cool the servers.
And that's just the operational cost.
Right. You also have to think about the upstream stuff, like the embodied emissions. That's the carbon cost of mining rare earth materials to make the chips.
And then the downstream problem, which is all the e-waste from old server hardware.
It's the whole system.
So the physical cost is massive, but where does this infrastructure actually live? Because it's often not in, say, Silicon Valley.
And that's where we get into some really critical social implications. AI's environmental footprint. It has a justice component.
How so?
These data centers are very often built in low-income or rural areas.
Yeah.
So you're concentrating burdens like heat, noise, and, of course, water depletion on vulnerable communities.
And they often don't even know it's happening ahead of time.
Often without their prior awareness or consent, yeah. It's a classic environmental justice issue.
That really complicates the whole narrative. But, we have to be careful not to paint AI as this total villain, right?
Absolutely not.
Because the sources are clear that it can also be a powerful climate solution.
It can. It can help optimize renewable energy grids. It can monitor deforestation on a global scale, model atmospheric systems. The key is finding that balance,
Between innovation and stewardship.
Exactly. And this is where we can connect that huge infrastructure problem back to the phone in your hand.
The carbon cost of our clicks lesson?
Right. The students in this lesson actually measure their digital activities. And you might assume an AI chat is the most expensive thing you can do, but the data, it shows some nuance.
And this is the part I found really surprising. Streaming one 30-minute HD video actually consumes nearly twice the energy of one short AI chat.
It's because of the sustained data transfer, right? It's constant.
So even though the AI model's training scale is enormous,
that little data point tells us that small behavioral shifts, like maybe just lowering your video resolution, they actually matter a lot.
Alongside pushing the big tech companies to commit to renewables for their data centers.
Of course. So I guess the core takeaway here is that AI is not immaterial. Not at all. Its footprint involves these complex, very physical systems of energy, water, materials. Every single byte has a real-world cost.
So what does this all mean for you, the listener? It sort of forces you to ask that difficult question about necessity.
It does. How can innovation be balanced with real sustainability? And I think you have to ask yourself, does every quick question you have really need the power of an AI chat?
Or is a simple web search good enough sometimes?
Is it sufficient? And that's really the point. It's about transforming that awareness into informed ethical action, thinking about our planet's resources before we click.